Hi, welcome back. So we're going to continue on, but now we're going to talk about the derivative from a table. So for the first question is, we want to be able to find out where the function is increasing. And they give us this table with all these derivatives. So we want to find out where the derivative is 0 or d and e. And I can get that from here pretty easily. Now, I'm going to get, the derivative, of course, at 0 is undefined, so 0 is going to work. At 1 the derivative is 0, and at 2 the derivative is undefined. Now you got to be careful. Now notice we're only told everything from only from 0 to 3, but our domain goes from -3 to 3. But they tell us that the function there is even. So because of this even symmetry, this tells me that it's going to be symmetric about the y-axis. Okay, so we'll talk about it. Let's think of a function that is symmetric about the y-axis. Kind of like a parabola right there. If I do the parabola right there. Notice over here, it's symmetric means it can look the same. They're mirror images, but remember, mirrors are opposite images of themselves. So over here, if the slope here is positive, on the other side of that mirror, the slope is going to be negative. So because of that symmetry, I also know that both plus or minus 1, and the same thing with the 2, will also give us that. So when we do our sign chart, we are going to try to keep in mind about that symmetry here. So my critical numbers are at -2, -1, 0, 1, and 2. So I know the slope between 0 and 1, that's this part right here, is going to be negative. Between 1 and 2, the slope is also negative. And between 2 and 3, the slope is positive. So this is going to go down, down, and away, and up. Now, because of that symmetry, remember, that symmetry is very important for us. Even if I do something like this, a W right here, notice, this, if I go opposite, ready? Negative slope, positive slope. Positive slope, negative slope right there. So the slopes alternate. So the slopes reflect, except they're going to be in the opposite direction. This is going to be positive, positive, and negative. So where are we increasing? We can now answer that. F is increasing on the domains -2 to -1, or -1 to 0, or 2 to 3, and that is because the first derivative is positive. When working with concavity, it's going to be a little bit different. We're still going to be doing our possible points of inflection. And kind of the same idea. Where is the second derivative? 0 or d and e. And that's going to give us, look at the second derivative. 0 is undefined. 1 is 0, so 1 is a possibility. And 2, it will also undefined. Now again, because of symmetry, we also do the plus or minus thing, because it's symmetric. But when we do our sign chart, it's not like here. If it's symmetric about the y-axis, take a look here. Here it's concave up, and on the opposite side it's also concave up. So concavity is going to be preserved. So this is preserved in symmetry. So in this case, right here, concavity is going to be preserved. So let's see here. So we go from -3 to 3. We're going to have, again, 0, -1, -2, 1, and 2. Our second derivative. Now, between 0 and 1, we know that the concavity is positive. So we know that's positive. Between 1 and 2, concavity is negative. Between 2 and 3, negative as well. Concavity is going to be preserved. We can see that in the graph up here in our little example. So if one side's concave up, the other side's going to be concave up. Right there. So let's see here. That was concave down. So this is going to be positive, so concave up, negative, concave down, negative, concave down. So we can say that this is concave down, so f is concave down on the following: -3 to -2, or -2 to -1, or 2 to 3, and that is because the second derivative is less than 0. All right. And now our POIs, of course, this is where concavity is going to change. Looks to change at -1 and +1. Looks like we only have 2 of them. So we have POIs at x equals ±1, and that is because 1, the second derivative, let me write that a little bit nicer here. And that is because 1, the second derivative is 0 or dne, and 2, the second derivative changes signs there. Now, the next question says find the x-coordinate of the absolute maximum and absolute minimum, and yeah, this is our candidates test. Can't spell candidates, right? So this is going to be our candidates test. It's going to become big for us in about another day. So we are critical numbers, which we already have. That is our 0 ±1 ±2, and you need your endpoint, which is x going to be ±3 from our domain. Setting this up right here, x and y. So we got -3 and 3, -1, oops, sorry, -2, -2, -1, -1, 0. So I'm going to draw these here just so I can kind of see the differences between them all. There's a lot there. Now, for some of these, I actually have the value. So if I go up to the table here, I know the value at 0 is 1. So the value at 0 is going to be 1. The value at 1 is 0. The value at 2 is -1. And because of symmetry, I know this is going to be 0, and that's going to be -1. Now, the only thing I don't have is my values at 3 and -3. So let's see what the sign chart is telling us again. Remember what the sign chart is? So let's look at our sign chart again, the first derivative sign chart. Remember we had from -3 to -2, -1, 0, 1, 2, and there's 3. And our signs are up here. Negative, positive, positive, negative, negative, positive. So it's going down, up, up, down, down, up. So I'm looking at here. It looks to me that I do have a minimum at -2 and a minimum at +2. Now notice at this point right here, it never goes any lower. Notice, I mean, it does go down at -1, but it's going down afterwards. So it's like from like 0 to 1 it's going down, then from 1 to 2 it's going down again. So it just keeps going down. So because it never goes back down again, this is kind of at these 2 points, that's getting terrible. Right here, we're going to have our absolute minimum because we're going down. So it looks like this, goes down, up, down, up. So it looks to me at those 2 points, those are going to be the same value because of symmetry. So I can say that my absolute minimum occurs at the 2 x values there, at x equals ±2. So what about my absolute maximum? Well, let's think about it. It goes down, and up. Now that's going to be a little bit harder to do because we don't know the values at 3 here. Because we don't know the values at 3, well, I don't know which of these 3 will be my highest point. So right now the absolute max is going to be an I don't know yet. Because unless I knew these values, I can't compare the 3. I know the value at 0 is 1, but I don't know what's happening afterward there. So I can't really verify what it's going to be here because I would need to know more information about it. So we don't know that one yet. But we can guarantee the absolute minimum because of symmetry. All right, the next question says, this is a really cool question. This is an AP question, multiple choice. It says, do the values at k in the table suggest that the function of k is concave up or concave down? This is a really cool way to understand about concavity. Concavity is the change in the derivative, the first derivative. In other words, it's how is my slope changing? And it's really kind of cool. Really quick way to answer that, ready? If I find the slope between these 2 points, ready? I can find the slope, that's just my A rock. I would do 3.8 minus 4 over 1.2 minus 1. And if I were to simplify that, I would get negative 0.2 over 0.2. And of course, this is a negative 1. That has a slope of negative 1. Well, let's go to the next 2 points and see what happens. Same thing, 3.6 minus 3.8 over, and if I subtract those, that's just 0.3, or this becomes negative 0.2 over 0.3, or negative 2/3. That's a negative 2/3. There we go. If I did the next two, same thing. I would get 3.4 minus 3.6 over, and again, this is just going to become 0.4, and that becomes negative 0.2 over 0.4, which is negative 1/2 for us. And I can already kind of get the idea. Look at this, right? Let me make this a little bit nicer here. This should be a negative 2/3. There we go. Now, what's kind of going on here? Notice I'm going from a negative 1 to a negative 2/3 to a negative 1/2. Notice the slopes are increasing. Therefore, that's telling me this is concave up. Remember, if the slopes are increasing, that's the definition from earlier of concave up. I'm going from a negative to a positive. I'm going from a negative to a less negative. So therefore, we can say f of x is concave up. All right, I hope you enjoyed this video. I'll see you all later. Bye-bye.